So here's a similar quadratic equation, x squared plus 2x equals 0. Again, I just started off by making a model for this equation. So I started off by just drawing off an x squared tile. On your desk, you can actually use your tiles to make this figure if you want to follow along. I have two x's, so I went ahead and placed one x on one side, another x on the other, making sure that my lengths stay the same on both sides so I can make a perfect square. And here I don't have another tile. I need an extra tile, right? I need to have one more unit tile to make this a perfect square. So what I can do is add one tile but take away another tile. So really I'm not adding or subtracting anything. It's staying the same, but it's helping me create a perfect square. So if we look back to our equation, we have x squared plus 2x, and I'm going to add one tile and take away one tile. So I'm not really changing my equation, I'm just adding by 0 really. So, okay, this looks familiar to me, x squared plus 2x plus 1. That's the similar problem we did over here, where we had this equation is equivalent to x plus 1 squared. So that's where I got this term here, just from previous work that we had already completed. And we still have our minus 1 term. So again, I want to solve for my value of x to find the two roots that satisfy my quadratic. So I went ahead and added 1 to both sides, leaving me with 1 is equal to quantity x plus 1 squared. Taking the square root of both sides, we'll have x plus 1 is equal to either the positive or negative square root of 1. And we're left with two different equations here. X plus 1 is equal to negative 1 and x plus 1 is equal to 1. And from that you can solve the values for x.